Okay, folks, today we're going to talk about average atomic mass. What data must you know about isotopes of an element to calculate the atomic mass of an element? Well, one, you need to know the mass of the individual isotope. And the second thing you have to know is how much is there. So percent abundance. For example, if I have an isotope that weighs 10, has a mass number of 10, and one that has a mass number of 11, and 95% of it is 11, and only 5% of it is 10, then it's going to be much closer to 11 than it is to 10. In fact, it's going to be 10.95. So what you're trying to do is figure out your percent abundance. You need to know both of these numbers, the isotope mass and the percent abundance number. All right, so here we're given, for lead, we're given those pieces of information. Here's your mass number. You have to calculate it. All right, this is going to be 204. This one's going to be 206. This one's going to be 207, and this is going to be 208. And here are your percent abundance numbers. Okay, so let's recall how to do this. We did this in the podcast. So we take our mass numbers, which are in this case 204, and we're multiplying by a percentage. Now we have to convert this into a decimal. So that's 0.0137. We're going to have 206, and 207, and 208. And respectively, they're going to be multiplied by, this is 26%, so it's 2626. This is 20%, so it's 2082. And this last one's the biggie. It's 5155. So over 50% of it is 208, which tells me that my mass is going to be obviously less than 208, but probably close to 207 or maybe a bit bigger than 207. Okay, so we actually take these numbers, we multiply them together. All right, now I've already done this, and I realize you're probably going to do it with a calculator, which is fine for what we're doing right now. Again, on a test, we're going to make these numbers easier for you so that you can do them without a calculator. But this first one's going to come out to 2.7948. The second one is going to come out to 54.0956. Your next one is 43.0974, and then your biggie is going to be 107.224. If I add all of these together, I get 207.2118. Now, in reality, I can only have 3 sig figs here because I can only have 3 sig figs here. In fact, all of them can only have 3 sig figs. So when I round at the end, I'm just going to get, the best rounding I can really do is 207 AMUs is going to be my average. Okay, my weighted average. You want to keep the other numbers, they're not legit, really. Okay, so lithium has 2 naturally occurring isotopes, and it gives you the atomic mass, and it asks you what's the percentage of naturally occurring lithium-7. So let's go back and see how we did this. Well, if you remember, we took the mass and we multiplied by a percent. And we then took the next mass and multiplied it by the next percent. And we did this, and when we were all done, we added all those numbers together to come up with a total. So if I look at this information, I have lithium-6, so I'm given my mass right there, and I'm given my mass of lithium-7. And I'm given what the average is. But what I'm not given are my percentages. So, how do I do this? Well, in all honesty, this is an algebra problem. Okay, this is an application of skills that you should have, specifically algebra skills. So let's look at what those are. We have our first mass, which is 6.015, and I'm going to multiply that by the percent of lithium-6. And I'm going to add that to 7.016 times my percent of lithium-7. And that entire thing is going to give me 6.941 atomic mass units. Well, I've got the percent of lithium-6 and the percent of lithium-7. Well, how do I know what those answers are? Those are 2 unknowns. Well, yes, but no. Remember that the percentage of lithium-6, percent of lithium-6 plus your percent of lithium-7 have to equal what? Of course, they have to equal 100%, right? Or in decimal terms, 1. So if I'm going to call this, let's call it P for percent. Then this one, my percent of lithium-6 plus this other percentage have to equal a total of 1. All right? So this is going to be 1 minus P. All right? So that's what that thing is. All right? So I can plug P in for here, and I can plug 1 minus P in over there. Right? Does that make sense? It doesn't matter which way I go, but that's cool. All right? So let's go and do this. So I have 6.015 times P plus 7.016 times 1 minus P, which is all equal to 6.941 AMUs. So now I take this and I distribute 0.15 P plus 7.016 minus 7.016 P is equal to 6.941. All right. Well, what I'm going to do is use my calculator a little bit, but let me combine like terms. All right, you'll notice that I have something with a P in it here and something with a P in it there. So I'm going to go 6.015P minus 7.016P. You'll notice I'm going to get a negative answer there. And I'm going to combine my just straight numbers on the other side, 941 minus 7.016. All right, that's also going to give me a negative number. So let me just write down what I'm going to come up here, and let's see, where am I? I'm going to come up to this point. Sorry, I lost my cursor again. There we go. So now, if I work this out, I get negative 1.001p is equal to negative 0.075. Right, I've come up here, guys. I just need more room. All right, so now I divide both sides by negative 1.001, so I get P is equal to 0.0749, which is equal to 7.49%. So my percentage of lithium-6, this is my percent of lithium-6. My percent of lithium-7 has to be 1 minus that, which is going to be 92.51%. So what did it ask? What's the percentage of naturally occurring lithium-7? So my answer there is 92.51%. Okay? Long problem, but it's using your algebra skills, and this just kind of goes to show where you start applying those skills that you have from algebra. Okay. Number 4, what's the atomic mass of an element, and how does it differ from the mass number? Well, the atomic mass is an average, whereas the mass number is simply the number of protons plus the number of neutrons. Right? So your atomic mass is an average, the weighted average, and that's what we've been working on. And your mass number, on the other hand, your mass number is the number of protons plus the number of neutrons. And that's all it is. Okay? Okay, imagine that you're standing on top of a boron-11 nucleus. Describe the number and kinds of subatomic particles that you see. Well, now we have to look at what boron is. Well, boron is number 5, and we're told that this is isotope with a mass number of 11. So we have to see 5 protons in the middle. We have to see 6 neutrons, because 5 plus 6 gives us 11. Right? So we have to do that. And, of course, when you're looking out from the nucleus, you're going to see electrons, and because we do not have a charge, the number of electrons has to be the same as the number of protons. Okay? All right. if we add 3 more neutrons to an atom of phosphorus 30, what would the charge on this atom be? Well, it doesn't matter how many neutrons you add. Neutrons are neutral. So if I have an atom of phosphorus 30, which is already neutral, because it's an atom, it's not an ion, so the charge would still be 0. You haven't changed it. So it has absolutely no impact on the charge. Now, what would the mass number be? Well, that certainly is different. Now, you should be able to just look at this and tell, but I'm going to write it up anyway. Phosphorus is number 15, and we said it has a mass number of 30, but we're going to add 3 neutrons. Right? Each one of those has 1 atomic mass unit, so instead of having 15 neutrons, we'll have 18, so that would be phosphorus with 15 and a 33. Okay? So, that's it. I hope you understand this. If you don't, come see me. I'll be more than happy to help. And I'll see you in class. Have a good day.